What's up, guys? Welcome to the start of my geometry series where I'll go over the geometry aspect of maths. By the end of this video, you should understand what Pythagoras' theorem is and how to solve exam questions, well, harder questions, using Pythagoras' theorem. So let's start with a basic example like this, right? Notice this triangle. It has a right angle, which means that we can use Pythagoras' theorem, which is that the opposite squared plus the adjacent squared is equal to the square of the hypotenuse. The hypotenuse is simply the angle opposite the right angle. Yeah? So in this case, our opposite and adjacents don't really matter in this case. This will refer to something that we'll look over in trigonometry. So, for this example, we know that the smaller sides are 2.8 and 4.7. So therefore, h squared is going to be 2.8 squared plus 4.7 squared. And if we plug that into our calculator, we should get an answer of 29.93. And now what we need to do is we need to square root both sides. So h is just going to be the square root of 29.93, which in this case will be 5.5 centimeters to 1 decimal place. But what about if we have the smaller side, which is unknown? Well, remember what we said, the opposite squared plus the adjacent squared is equal to the hypotenuse squared. But we know what the hypotenuse is. So all we're going to do is rearrange to make one of these the subject. In this case, I'm just going to say it's the opposite. So then, the opposite squared is just going to be the hypotenuse squared minus the adjacent squared. So, let's take a look. So in this case, it will be 4.2 squared because 4.2 is the largest side, minus 3.6 squared. And if we plug that into our calculator, we should get an answer of 4.68. We then take the square root of that, so our answer will be equal to the square root of 4.68, which will just equal 2.16, or 2.2 to 1 decimal place. We can even use Pythagoras' theorem for something like this, where we're trying to find the diagonal of a rectangle. We know that a rectangle has a right angle everywhere, right? But we know that D in this case is the hypotenuse because it's opposite the right angle. So, we can say that h squared is equal to o squared plus a squared. So therefore it's equal to 5 squared plus 10 squared, which is equal to 125. And so therefore D, or h in this case, I'll just call it D. D is just going to be the square root of 125. The square root of 125 is going to be equal to 11.2 centimeters to 1 decimal place. But what about if there's something like this, where in this case we're going to have to take multiple steps in order to find what x is? So, this is the triangle that we're after, and this is our unknown, this hypotenuse here. So again, h squared is just going to be equal to opposite squared plus adjacent squared, which is equal to 3 squared plus 8 squared. And if we plug that into our calculator, we get an answer of 73. H is equal to the square root of 73. Let's leave it at that, just for now, because this is not our final answer. So let's label that on our diagram. This is now root 73. Okay? Now let's take a look at this triangle again. We can see that the side that's opposite the right angle is 10. So in this case, we're going to use opposite squared is equal to hypotenuse squared minus adjacent squared. So now this is our adjacent because it's not the largest side. 10 is. So let's plug it in. So we're left with 10 squared minus 73, which is equal to 27. So then x is equal to the square root of 27, which is equal to 5.2. Again, to 1 decimal places. Yeah? What about something like this? We're told that in this case, these two sides are equal. So how are we going to work out what x is? Well, these lines simply mean that it's equal. So this is also 6 centimeters. And so therefore, x squared is just going to be 6 squared plus 6 squared, which is equal to 72. And so therefore x is equal to the square root of 72, which is equal to 8.5 centimeters. But what about if it's done in reverse? We're given what the hypotenuse is, but we're not given anything else. How are we going to do it in this case? Well, remember what we said before, that h squared is equal to opposite squared plus adjacent squared. But in this case, the opposite, right, is equal to the adjacent. So therefore, we can say that h squared is equal to opposite squared plus opposite squared. You could say adjacent squared plus adjacent squared, which is the same as 2 opposite squared. And now we can solve this like an equation. So 10 squared is equal to 2 times opposite squared. So then opposite squared is going to be 10 squared divided by 2, which is equal to 100 divided by 2, which is equal to 50. And so therefore the opposite is just going to be the square root of 50, which is equal to 7.1 centimeters to 1 decimal place. Thank you guys for watching. I hope this video made sense. If you guys liked it, consider subscribing. If you have any further questions or comments, ask me down below or join my Discord server for some personal advice. If you guys need any extra tutoring, drop me a business email and I can organize a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.